Today we're going to talk about solution to a linear equation in two variables. So far we've talked about linear equation in one variable. What's a linear equation in two variable? If we have ax plus by plus c equal to 0. If you remember, linear equation in one variable was ax plus b equal to 0, where a and b were constant. If the equation involves two variables, in this case x and y as your variables, then we have a linear equation contains two variables. C, b, and a are constants, and on the other side you have equal to either constant or 0. Doesn't really matter. So ax plus by plus c equal to 0 is a form of a linear equation in two variables. Here's an example of it. As an example, 2x plus y minus 5 equal to 0. And if you compare, you will have ax plus by plus c equal to 0. And what we have is a is 2, b is 1, since there is no coefficient here, is coefficient 1, c is negative 5. All constant values. Now the question is, how do we solve this? And the answer is not that simple, because you have multiple solutions. And what are the solutions? The solution is so if you think about it, the question is what x and y's satisfy that equation. That means, for example, if I pick x equal to 1 and y equal to 2, does that work? That means if I pick the point 1 and 2, does it work by replacing into this equation? So let's try it. 2 times 1 plus 1 times 2. Actually, there is no need for the 1 times 2 because we have just plus y. Sorry. Y is given 2 minus 5 equal to 0. So I replaced 1, and let me erase this up here so you do not get confused. I'm replacing 1 and 2 into the equation, the given equation, 2x plus y minus 5 equal to 0. And I want to figure out, is that going to give me a true statement or a false statement? That's what I'm trying to do. So I replaced 1 and 2. These are the x and y values. Okay, does it work? 2 plus 2, 4 minus 5 equals 0? Not really. So this is a false statement. What does it tell me? That means if you pick these two numbers, 1 for x and 2 for y, you do not satisfy the equation. So it tells me that 1 and 2 is not a solution. So how do I find the solution? Do I need to go through every number and check to see, for example, if I pick 1 for x and 3 for y, does that work? Let's try this. 1 and 3. I'm replacing 1 and 3 into the equation. 2 times 1 plus 3 minus 5 equal to 0. And you will see that there is a true statement. That means 1 and 3 is a solution. Is that the only solution? Maybe there are more solutions. So let's try another one. Let's try another point, something like x equal to 0, y equal to 5. If I try that, I'll get 0, 5. 2 times 0 plus 5 minus 5 equal to 0. And you'll see this is a true statement. This means this is a solution as well. 0, 5 is a solution. And there are multiple. You can try another one. X equal 0.5, y equal to 4. You try this point, 0.5 and 4. You'll get 2 times 0.5 plus 4. Again, I'm replacing it all into this equation. See if does that really satisfy the equation or not, equal to 0. And you'll see this is a true statement, therefore this is a solution. And you will see that there are infinitely, actually, many solutions. So how do I find all these solutions? This is where graphing helps, because you do not want to find infinite number of points and just write them out. What you do is you try to graph them. And we learned, let me write down the equation again, 2x plus y minus 5 equal to 0. This was the original equation. We learned the rectangular coordinate system. So here, we draw the rectangular coordinate system. Every point in 2 dimension, x and y, belongs to this space, x and y axis. So here you can pick x and y values and check to see if they are the solution. Or what you can do is you can pick an x value, something like 0, and try to find out if I replace 0, what y value satisfies the equation. So for example, if I replace 0 into the equation, what do I have is 2 times 0 plus y, if I do not know the y, minus 5 equals to 0. And solve this equation. 2 times 0 is 0. So you have y minus 5 equal to 0. And you will learn that y must be 5. So I say 0 and 5 is a solution. The point here is x. I picked x equal to 0. I found out the y must be 5 to satisfy the equation. So the point xy is 0, 5. How about if I pick another one? If I pick x equal to -1, for example, is it possible to get a solution? Let's try that. Let me pick a different color. Again, these numbers, I'm just randomly picking and find their solution. 2 times -1 plus y minus 5 equal to 0. What do you get is -2 plus y minus 5 equal to 0. Solve this equation, you will get y is 7. So now you have another solution, -1 and 7. That means if you replace -1 and 7 into this equation, original equation, it satisfies that equation. That means it's a solution. You can try another one. 2, replace 2 in there. 2 times 2, 4 minus 5 will give you -1, so y must be 1. You'll see there is a 2 and 1. Satisfies this equation. You can try these numbers. So how do you show those numbers? On the xy coordinate, find out the location of these points, 0 and 5. 0 and 5, let me call this 5. That's one of the points. And then you have -1 and 7. This is -1. 7 somewhere up here. This is a point -1 and 7. How about 2 and 1? 2. Here's 1. This is rescaling. I didn't rescale this correctly, so the points may be... sorry. Undo that. The points may not be that accurate where the location is, but you can pick... you can make the scaling correctly. This way it's more accurate. You can pick another point if you want. You can values for y. You can pick values for y. For example, you can pick y to be something like, I don't know, 3 if you want. Try 3 for y. Solve for this equation. So I'm replacing y with 3. What do you have is 2x plus 3 minus 5 equal to 0. 3 minus 5 is 2. So you have 2x plus, minus 2 equal to 0. And you'll get that x must be 1. So x is 1. This is not plus, that is negative. 2x minus 2. Okay, so I have a point 1 and 3 as well. 1, 3. Here's 1, 3. You pick one of the variables, figure out what the other one is. You can continue by picking more points, and you will see this trend. All the points in between still satisfy that equation. If you remember, I picked 0.5 earlier. We go up a bit. We tried 0.5 here. And what do we got for y? What we got for y was 4. And we said 0.5 and 4 satisfy the equation. Therefore, there is a solution. So here, 0.5 and 4, somewhere here. There's a point there with 0.5 exactly y value of 4. If you pick 0.3, you will find the point on this line. And if you connect all those points, you create a straight line. What does it tell you? That means all the solution to this equation, this linear equation, are on that line. Every solution belongs to that line. So if you pick a point here, out here, something like 3, for example, and 3, it should not satisfy that equation. Otherwise, you did not graph the correct solution set. So this graph that we have, this red line is your solution. Any other point does not belong to that equation, does not satisfy this equation. So for example, if you pick 3 and 3, replace it in the equation, what do you get is 2 times 3 plus 3 minus 5 equal to 0. And you will see that this is 9 minus 5, 4. It does not satisfy the equation. It's a false statement. Therefore, all the solutions are, the points belong to this red line. So the solution to a linear equation in two variable, it turns out to be a straight line. That's why we call it a linear equation, because the outcome is a line. Okay, in one variable, the outcome is just points, but in 2 dimensions, you will see that you have straight lines as the solution. Okay, how about the format of a linear equation? There is a couple of forms of a linear equation. A very consistent form that you always see is ax plus by plus c equal to 0. This is the very common form of a linear equation. But there are standard and slope intercept form that helps you graph the linear equation much faster. One of them is the standard form. Here is the format of it. M is what we call the slope, and x1 and y1, this is just a point. It's a point on the line. That subindices 1 is just to make sure that you know it's not a variable anymore. There's a given point. The 1 point is given. And the slope intercept form is y equal mx plus b. Again, m is the slope. B is what we called, actually is 0 on b, is what we call the y-intercept. I'm going to come back to this and explain it later. But at the moment, that's just to understand. This b is a y value where you cross the y-axis. So if it was 3, for example, you cross the y-axis when you graph this line. Here, this 5 that you see, the point where you cross the x-axis, this is exactly b. That's why we call it the y-intercept. It intercepts the y-axis. The form of a linear equation helps with the graphing. So the standard form is the way that the standard form looks like. This is the way the slope intercept form looks like. M is called the slope, and it's just a ratio. So M as the slope is the ratio of rise over run. In other sense is change in y divided by change in x. And x. This tells you how much movement you make along the x direction, then how much movement you make along the y direction, if you want to start from a point to another. For example, if we go back to this graph, I pick a point. Let me change the color to yellow. I pick a point here and move to the right, then come down. I'll hit another point on the number line. The amount of movement along the x and amount of movement along the y, the ratio corresponds to that slope, because it's a unique triangle that you can always create. The ratio of that those sides to each other is a fixed value. We will discuss this slope later as well. It's just the format that I want you to see. Okay, so these are the two forms, standard and slope intercept form of a linear equation. How about graphing a linear equation in a slope intercept form? Okay, so let's say you're given an equation in the form of y equals mx plus b. This is the slope-intercept form, and we want to graph it. That means you want to find all the solutions. You can always do this. You can always pick x values and find the corresponding y value. This is always possible. And find all the points, x and y. This is not difficult, so let's try 0, 1, 2. You can go negative number if you want, -1. But since I know the result is aligned because it's a linear equation, 2 points are just enough. If I know 2 points, then I know how to draw a line passing through those 2 points. So how do I find the y value? Replace x with 0 into the equation. If you replace 0, what do you get is, I'm replacing x equal to 0 into this equation. What do I get is y equals 2 times 0 plus 1. What is y? Y is 1. So therefore 0 and 1 is a point. If I replace 1, what do I get? I get y equals 2 times 1 plus 1. For x, you'll get y is 3. You'll get 1 and 3. And so on. You can continue. You'll get 5. And this would be -1 as well. Try to find out these points by calculation. You can do this calculation. Replace -1, for example. You will get y equals 2 times -1 plus 1, which is simply -1. That's why we get -1 for y. So how do we graph it? Again, simply draw the coordinate system. Find those points. Again, 2 points is enough to draw a line, but if you want it to be more accurate, 0 and 1. If you know it's a straight line, this should be enough. 1 and 3 is 1, 1, 2, 3. That's another point. So if I look at 2, 1, 2, and 5, and so on. -1 and -1. That's another point. Draw a line passing through these. Straight line. Well, this line is wobbly, but I think you guys can draw it with the ruler. Okay, so this is the solution. This line, red line, is the solution. It's the solution to what? It's a solution to this equation. That means any number that you pick on this number line, on this straight line that we draw, the red straight line, to satisfy that equation. It doesn't really matter where it is. I can pick it here. It has some coordinate. Whatever that coordinate is, this x and y, if you find these numbers, it should satisfy this original equation. Otherwise, that should not be on that line. And the same idea, if I pick a point outside here or here that doesn't belong into the line, it should not satisfy that equation. Okay, so some information that I can tell you already. If you look at this later on, we will discuss it. As I mentioned, this is a slope-intercept form. This number constant here, +1, is that location that you intercept the y-axis. This was the y-axis. +1 is the location when you intercept the x-axis. If you know this point, then the graphing would be easy. If I know this point, 2 here is the slope. If you compare, you have y equals 2x plus 1. B is 1, slope is 2. Coefficient of x is slope. What does it mean? That means if you make one movement along the x, you have 2 movement along the y. That's what it tells you. That means change in y divided by change in x is 2 divided by 1, which is basically the slope. I do not want to get into it, but it's just a preview to what we were going to discuss as a slope definition. It means wherever you start and move 1 unit right, 2 unit up. Sorry about that. If you move 1 unit right and 2 unit up, you're going to be always on the line. Doesn't really matter. 1 right, 2 up. This tells you that information. You start from here, move 1 left, 2 down, you're going to be on the line. And these are not great ratio. I cannot draw a straight line. Sorry about that. Here. You're going to be on the number line. So that slope is just tells you that the ratio is a fixed value. What if the equation is given in a standard form? And if just to remind you of it, standard form was y minus y1 equals m times x minus x1. This is the standard form of a line. And again, m is the slope, and there is a point x1 and y1. And in this case, if I compare it, I'll see that the slope is this coefficient here, -2. And the point given is x minus 3, so x minus x1. x1 must be 3. y1 is 1. This is y1, this is x1 if you compare. y1, x1. And this is the slope. If it's given in that format. It's not always given in these forms, but you can try to reproduce the format by moving stuff around. But at the moment, let's assume this is given and you want to solve this equation. What do? No different than what we did last time. You can always pick x and y values. I'll pick an x value, find the y value. You can pick the y value if you want and find the x value. It doesn't really matter. You pick one of them as fixed value, the other one is a variable, you can figure it out. It's always easier to pick the x. So I'm going to pick -1, 1, 2, and 3. Something like this. So here, let's try this. Let's pick -1 for x. What do you get? The numbers are going to be a bit larger, but let's try it. Y minus 1 equals -2 times x. Sorry, we picked x already. We picked x as -1, so -1 minus 3. And you can solve this equation. It's a linear equation. Add the 1 to both sides, you'll get y equals 1. This is -4. -2 times -4 is +8. So you'll get y equals to 9. So you have the point -1 and 9. Maybe the choice of -1 is not a good start because the number y is very large. So when you graph the x and y axes, you have to go up to y equal to 5. What if I pick x equal to 1? You can pick x equal to 0 as well. What if I pick x equal to 1? What do I get? Again, same idea. Y minus 1 equals -2 times 1 minus 3. And if you solve this one, you'll get y is 5. You'll get 5. You'll have the point 1 and 5. What if I pick 2? Y minus 1 equals -2 times 2 minus 3. You'll get y equals to 3. If you pick 3, you'll end up with 1. These are all calculation. You should be able to replace 1 and find the other. 3 and 1. Sorry, my handwriting is not that good. 3 and 1. Okay, so what's the next step? We found these solutions. These are not all the solutions. These are just a sample. We found 4 points that satisfy the equation. How do I show them? Using the x and y coordinate. I'm going to pick the smaller numbers. I'm going to pick these two. Having 2 points is enough. You can pick these 3 if you want. So here, 1, 5, 1, 5, somewhere here. The point. 1, 2, and 3. 2, 3, somewhere here. And 3. And 1. Let me rescale this back down a bit. Here, let's say call this 3. This one 1. And here 3. Well, I hope it's good enough. I don't want to be that picky, but try to be more accurate. Using Alex, there is already a point. They have the option to draw a straight line passing through 2 points. You don't need to be that picky as I am. So here we graph this. That means any other points the other point that we had, -1 and 9. We pick -1. It should be somewhere here along this line. It should be somewhere here at 9. And there must be a y value 9 exactly at that point. It's not any other number. It should be exactly 9. Okay. What does this linear standard form tells us? It tells us the slope. We already know the slope is -2. It tells us a point as well, 3 and 1, if you remember. But here, what we found was 3 and 1 as well. Means if you're given that point, you do not really need to find the point. It's already given. You can, based on the format, you can find that point. You do not need to solve for anything. You're given this point 3 and 1. And you're given the slope, -2. If you think about -2 means if you make one movement to the right, you have to make 2 movement down. This is -2, this is 1. Or if you make one movement left, you have to make 2 movement up. You'll get to this point. So the moment that I make 2 points, I can always draw a line through those 2. So based on the given format, there are shortcuts to graphing, but you can always draw this table. You can always draw this table and go through these points to find the solution. Okay. Beside the 2 lines, these lines are always either decreasing or increasing. We've not talked about vertical and horizontal lines. So there is the other case that you have vertical and horizontal case. These are specifically defined in 2 dimension. That means you consider there is still 2 variable. You still expect 2 variable solution. So let me mention a horizontal line. Think about this. If I tell you I have an equation, it has the form of 0x plus y equal to 3, and ask you to solve this equation. What would be the solutions? You pick numbers. I'll pick different x, find different y. This is a linear equation in 2 dimensions. 0x plus y. If I pick x equal to 0, what do I get for y? Y would be 3. If I pick x equal to 1, what do I get for y? 0 times 1 is still 0 plus y. Y must be 3 again. If I pick 2, I'll get 3. If I pick -1, y would still be 3. It doesn't really depend on x. Whatever x you pick, y value is always 3. And by the way, there is a shorter way of writing this equation. 0x is always 0. So I have y equal to 3. So how do I graph this? Here's 0 and 3. Let's assume this is 3. 1 and 3. 2 and 3. -1 and 3. So it tells you this line passes through all these points. What is the property? All the y values along this line are exactly 3. What type of line is it? It's a horizontal line. And so if you see a form of y equal to a constant, c, and they tell you this is a linear equation in 2 variable, that means you're discussing a linear equation with variable x as well, but now the coefficient of x was 0, so it disappeared. So you're still solving for a 2 variable. Turns out one of the variables does not really have any dependence. X in this case, you can pick whatever you want, but y is a fixed value. Y is a fixed value of 3. I have this line, which is a horizontal line. I can pick whatever I want for x. Y must be always that constant. In this case, it's that constant is 3. How about the vertical line? Vertical line is very similar. Instead of having 0x, you have you have x plus 0y equal to some constant. Let's say -1. That means whatever you pick for x, Here's what matters. If I pick 1 for x, I will have no solution. 1, here, try this. 1 plus 0y, 0 times y equals -1. 0y is 0. So you have 1 plus 0 equals to -1. There is no solution. Because if you simplify this equation, this means x equal to -1. That means you do not have the option to pick 1 for x. You always have to pick -1. How about y? What if I pick y 0? No problem. 0 times 0 plus -1, it's okay. What if I pick 1? That's okay. 2, 3, and so on. So it is important that you look at the restriction and say, in this case, I'm not allowed to pick any number except -1 for x. In the other case, it was we only had the option to pick 3 for y. So what does the graph look like? As we expect, it's a vertical line. Vertical line through the points -1 and 0. -1, 0. -1, 1. -1, 2. And so on. -1, 0. That's the point. -1, 1. -1, 2. -1, -1, and so on. The vertical line that passes through the point x equal to -1. This is the point x equal to -1. So this is the simplest cases, vertical and horizontal line. Vertical line, sorry, there isn't. That's the form of x equal to some constant. In this case, that constant is -1. Okay, and the graphing is not really difficult. These are the two examples of them. So it's important that you know that they're discussing graphing in two variables. It's not only one variable. If I don't tell you any information and say x equal to 2, that to you should mean, okay, 1 dimension, here's 2, that's my solution. But if they say it's a linear equation in 2 variable, then this means it's a vertical line because I have another variable. What is that variable is y. But there is no obligation over, okay, I can pick 0, 1, 2, whatever I want. 0, 1, 2. So there are infinite solutions. 2, 0, 2, 1, 2, 2, and so on. But instead, it's not in 1 dimension. It would be in 2 dimensions. You'll have 2, 0, 2, 1, 2, 2, and so on. All these would be solutions. That's why you have a vertical line. Okay, now let's discuss the slope. This is a very important topic. As I mentioned, as an idea of a slope is a ratio of rise over run. So slope by definition, slope of a line, it's change in y divided by change in x. And sometimes they use delta y divided by delta x, just as a notation. Delta is just the difference in y divided by difference in x. Or if you have 2 points, it is y2 minus y1, difference in their y values, divided by x2 minus x1, where x1 and y1 is a point, as well as x2 and y2. You have 2 different points. These are the coordinates of those 2 points. Here, let me show you an example. This is just a calculation. The example, find the slope of the line. Slope of the line passing through these 2 points. Passing through the points 0, 1 and 1, 3. So what you're given is 2 points. If you're given 2 points, 0, 1 and 1, 3, there is a line always passing through those 2 points. If I do not give you 2 points, then there are infinite lines passing through one specific point. I can draw the line any way I want. But by picking 2 points, you have a specific line. So what does the slope mean? The slope means the amount of movement that you make in this direction, the amount of movement that you make in the other direction, create this triangle. What is this ratio of the height divided by this other side? The vertical divided by the horizontal change. So what is the slope? Here. By definition, it is y2 minus y1 divided by x2 minus x1. You can pick one of this two to be x1 and x2, the other one to x1 and y1, the other one to be x2 and y2. So if you want, I'll pick this one to be x1. The corresponding y value is y1. The other one would be x2. This must be y2. The order doesn't really matter, however you want. But the y2 minus y1 would be 1 minus 3. x2 minus x1 would be 0 minus 1. I cannot write 1 minus 0 because I already fixed the y2 and y1, so I should follow the same order. 1 minus 3 is negative 2. 0 minus 1 is negative 1. What is the ratio? It is 2. You can think about it as 2 over 1. This is the same. What does it tell you? This tells you the amount of run here, the denominator, the numerator is rise. Rise. It means if you make one movement, this one movement in the x direction, you should move up 2 movement in the y direction. Starting from anywhere on this line. I make one movement in the in the right direction, and I have to make 2 movement upward. What if I want to go left? What if I pick this and say I want to make one movement in the left direction? But then instead of thinking about going positive direction, what if I want to go negative direction? Then your movement should be negative as well, because the ratio should be a fixed value. So it should come down 2 units. By doing that, you always stay on the line. If I start from here, it doesn't really matter. I stay on the line. If I go 4 units right, again, remember for every unit right, you have to move up 2 units. So if I make 4 units right, I have to move up 8 because I want to have a fixed ratio. 8 divided by 4 is 2. This is negative 2 divided by negative 1 is 2. 2 divided by 1 is 2. All these ratios are fixed constant. And what is that constant? That constant is the slope. So m is 2. Okay, so we already calculated 2 divided by 1. So the slope of a line passing through 2 points is just calculate the difference in the y's divided by calculate the difference in the x's. That's it. It's just one constant. What if the line is vertical or horizontal? If you remember 2 minutes ago, I mentioned that y equal to c, the horizontal line. Here's an example. I want you to pause the video and think about it. And say, here is an example, y equal to 3. This is a horizontal line. How do I find the slope? Think about picking 2 points and go through the definition. What are the coordinates of these 2 points? This is whatever number you want. 2. This one, 0. So what are the coordinates of those 2 points? 0 and 3. And the other one, 2 and 3. The y value is fixed because it's a horizontal line. So what is the slope? Difference in the y, 3 minus 3. Difference in the x, 2 minus 0. What you get is 0 divided by 2. What is that? 0. So what do I expect from a horizontal line? I expect the slope to be 0. Why is that? Because if you think about the rise over run, we never have a rise. You always move left and right, but you never go up. So if I don't go up, then the numerator of the rise over run should be always 0. There's no movement upward. So the horizontal line has always a slope of 0. How about the vertical line? I hope this one, you can think about it again. You can do this graphing. But if you think about it, based on the graphing, based on the rise over run, I have a straight line. If I pick a point on that and continue, I never make a move left or right. I only go up and down. So what does it tell me about the slope as rise over run? What do I know? I know the numerator is possible to change. You can go up or down. I can move up 2 units. I can move down 1 unit. But I will never move left or right. So the denominator is always 0. The numerator could be 1, 10, 100. Doesn't really matter. So when the denominator is 0, you have an undefined fraction. So what is the slope? Slope is undefined in this case. So if you have a vertical line, you have an undefined fraction. There is no slope. Slope is undefined. But if you have a horizontal line, slope turns out to be 0. Okay. Let's discuss x and y intercept. Later on, we will discuss equation of the line, how to find the equation of the line. These are just preparing you based on the graphing. Finding x and y intercept. So first, let's think about the x and y intercept and what is x and y intercept. Generally, it doesn't really matter if you are discussing a line or a curve or whatever. So let me draw a picture. Something like that. What is called an x-intercept is the point. Let me undo this graph, maybe draw it a bit better. Something like that. How about? Generally, the x-intercept means the point where you cross the x-axis. In this case, there are 2 points. This is the x-axis, this is y-axis. The points where you cross the x-axis, these two, let me call it point 1 and point number 2. 1 and 2 are called the x-intercepts. And point 3 here is where you cross the y-axis. Point number 3, they have coordinates, but I just don't want to write the coordinates before you understand the concept. So the point 1 and 2, they cross the x-axis. The graph crosses the x-axis as these 2 points. These 2 points belong to a curve, line, straight line. It could be, doesn't really matter. Those are the solution to an equation where the solutions belong to either x-axis or the y-axis. If they stand on the x-axis, they're called the x-intercepts. If they stand on the y-axis, they're called the y-intercepts. So think about this. If a point belongs to x-axis, what do you know about that point? There is a property that you know. What is the coordinate of that point? You may not know the x coordinate, but you definitely know the y coordinate. The y coordinate is 0. You don't have any information about the x. It could be -1, -2, -0.7, whatever. But you know for sure that the y value is 0. The same, if I look at this point, point number 2, what is the coordinate? I don't know the x coordinate, but I know the y coordinate is 0. So if I'm looking at the x-intercept, I don't know the x coordinate, but I know the y coordinate is 0. So if you're looking for the x-intercept, you always know that the y is 0. This is what you know. You figure out what is the x. That would be the question. How about y-intercept? Y-intercept is exactly the opposite. You don't know the y value, how much up and down is it, but you know that the x must be 0 because it belongs to the y-axis. The coordinate here is x is 0. So I know the x is 0, but I don't know what the y value is. I'm looking to find out what is that y value. So the information that we know about x and y intercepts is that x-intercept has y 0, y-intercept has x value of 0. It's very simple to see. If you forget it, always draw a picture and see, okay, if I'm on the y-axis, what is the information? I know x is 0. If I'm on the y-axis, x is 0. If I'm on the x-axis, y must be 0. Okay, let's do an example. At this point, we're only talking about linear equation, so finding x and y intercept for a linear equation. Let's try it with an example. As an example, I'm going to pick a linear equation, 2x plus 3y minus 6 equal to 0. Let me change the 6 to a different number. Minus 12 equal to 0. I tried to pick a number so you do not get fraction, so we can discuss it a bit easier. So here, question, find the x and y intercept. X and y intercept. How do we find it? First, let's look for the x-intercept. What do we know about the x-intercept? All these are points. They're not interval. Do not make that mistake. We're discussing x-intercept as a point. So I know that the x-intercept has the property that the y-coordinate is 0 because it belongs to the x-axis. So I replace y with 0 into the equation. So replace y with 0. Here, replace y with 0. So what do I get? Let me change this to a different color. Green. You'll have 2x plus 3 times 0 minus 12 equal to 0. And solve this equation. You'll get 2x minus 12 equal to 0. Move stuff around, you'll end up with x equal to 6. So what did we learn? We learned that x value must be 6. So I found out the x-intercept. That means if you're trying to cross the x-axis, if the graph crosses the x-axis, it only crosses at this point, 6 and 0. This is the only point that the graph crosses the x-axis. How about the y-intercept? How do I find the y-intercept? You replace x with 0. Because for y-intercept, I know x is 0. I do not know what the y value is. I just need to figure out what is that y value. So you get 2 times 0 plus 3 times y minus 12 equal to 0. And solve this. You'll have 3y minus 12 equal to 0. Sorry, my 0 looks like a 6. 0. And you can figure out that y is 4. So I have 0 and 4. So when do I cross the y-axis? I cross it at 0 and 4. This must be 4. Since I know this is a linear equation, and I already know 2 points of the linear equation, that means I know all the solutions. Where are all the solutions? All the solutions belong to this line. The line that passes through both of these 2 points. So if you find the x and y intercept for a linear equation, you already found the solution. Because normally there are 2 of them, but sometimes you have only one solution if you're passing through the origin. Then you need to find another solution beside that. Okay, so if you find the x and y intercept and there are totally 2 different values, then you can graph the lines simply by connecting those 2 points. It's not always true, but sometimes, for example, the both solution turn out to be this guy. They both only graph passes through this. Then you need a bit more information because it could be different type of line. It could be this line, it could be that line. So what you would need is one more point. You would need to figure out, okay, maybe I need to figure out a point so I can connect those 2. So you'll pick a different x, different y, just to figure out more points. Okay, I hope it is clear at this point. Okay. So let's discuss this very last topic as well for today. How about we graphing a line by finding the slope and y-intercept? So if you're given an equation, a linear equation, let me pick an example. You just need to write the equation. Let's say, let's do an example. Through an example, it's always easier to see. If you're given the slope, for example, a slope is given 2, and they tell you that the y-intercept is at this point, 0 and 1. Then they ask you to graph this line. What does it mean? It means I already gave you the information where the line or the straight line crosses the y-axis. It's given point 0 and 1. Here's 0 and 1. And then I gave you the slope 2, which means if you move Slope always means rise over run. If it doesn't have a denominator, put a denominator there and say 2 divided by 1 is still 2. This numerator is the rise, denominator is the run. I move 1 unit right, 2 unit up. So I got to the point 1 and 3. 1 right, 2 up because of the slope. Then I found another point. Draw a line passing through those 2 points, and I have the solution to the line that has this property. Slope 2, y-intercept 0 and 1. And that would be the solution. Very simple. So if I have the slope and the y-intercept, then graphing a line would be much easier. So what we will try to do is to find the slope and y-intercept. That would be the ideal case to graph a line. So here, we try with an example. Let's say you have 2y plus 3x minus 6 equal to 0. Let me do this. First, let's figure out what is the y-intercept, because we already mentioned this. Well, actually, let me show you this because it's better to do it this way. If you remember the y-intercept form, y-intercept was mx plus b. What is b? As I mentioned earlier, 0 and b is basically your y-intercept, now that we've discussed b. And what is m? M is the slope. So if I write this equation, this given equation, if I turn this equation into this format, then I already know the slope as well as I already know the y-intercept. Then it would be, the graphing would be much easier. So what I would do is I would write the equation by moving stuff around. I will keep the y on one side and move everything else to the other side. So I'm trying to isolate the y. So what do? I'll say 2y equals, I subtract the 3x and add 6, minus 3x plus 6. Then what do? I divide both sides by 2. Means divide everything by 2. Negative 3x divide by 2, as well as 6 divide by 2. You can divide them separately, you can divide them all together. I divide them separately, this way I can simplify. By the way, this is what I did. Divide by 2, divide by 2, divide by 2. Left side is simply y. I'm going to write it this way. Y equals negative 3/2 is a constant. Then x next to it plus 6 over 2, simply 3. Okay, now what is the question? The question is, what is the slope? Based on the shape, based on the format, this must be the slope, coefficient of x. So the slope is negative 3 over 2. What is the y-intercept? Y-intercept is given as 3. But do not write 3 only, because y-intercept is a point. So 0 for x and 3 for y. This is the coordinate of that point. So the graph, if I want to graph the solution, I'll draw this together. I will find this point first, the y-intercept point. So here is the y-intercept, 0 and 3. So this is 3. Then, based on the slope tells you how much movement do you make. This is rise, this is run. It means move 2 units to the right, 3 units down. So here, let's start from this point. Move 2 units to the right, 1, 2, 3 units down. 1, well, this graph is not that clear. Let me shift this a bit, sorry. Let me erase this, just to make the scaling more accurate. Okay. So here, let's say 3 is here. This is the y-intercept. Move 2 units right, 3 units down. Because we have 2 as a run and 3 as rise. Negative 3. The negative, you go opposite direction. 2, 3. Because from this location, from the 0 and 3, if I start and move 2 units right, I'll get to 2 and 3. 2 and 3. Then if I start moving down 3 units, I'll end up at 2 and 0. This is where I'll end up, which means that I'm on the x-axis. If I find the next point by doing this slope movement, 2 units right, 3 units down, then I have 2 points. Draw the line passing through those 2 points. And what do I have at the end? I have this. This is my solution. This is the graph to this equation 2y plus 3x minus 6. Using the slope y-intercept. You can graph the solution by just picking points, but if you use the slope-intercept form, it's much faster. Okay, I'm gonna stop here, and next time we discuss the equations for lines in different forms, how to get the equation and how to calculate.